differentiate a constant, it always gives a 0. Every time you look at that differentiate constant, these are numbers that doesn't have variables. Okay, so now our dy over dx, which is a gradient function, is equal to 2x. X to the power 0, it's 1. Negative 3 times 1 is negative 3. All right, so now say dy over dx is equal to, we have now our gradient function negative 3. So for us to find the gradient now, say gradient is equal to, since e point emitting a e line 9, we use where there is x, we put 2. So say 2, all right, minus 3. So now our first gradient is equal to 2 times 2 is 4 minus 3. So our gradient to be 4 minus 3 is 1. So now we know the gradient for this curve at this point. Our gradient there is 1. So we need now to know the gradient for this line now. So we say 1 times second gradient equal to negative 1. So 1 times second gradient is second gradient. So our second gradient is equal to what? Negative 1. Okay, now we know the second gradient. So now that we know the second gradient, we bring in the idea of the equation of a straight line, because now we want to find the y-intercept, which is c. So tizakamba kuti y is equal to mx plus c. Where there is y, we put negative 6 equals, where there is gradient, we put negative 1. Where there is x, we put 2 plus c. Okay? Then negative 6 is equal to negative 1 times 2 is negative 2 plus c. Then group the like terms. E negative 2 comes to the left side by additive inverse, becomes positive 2. So negative 6 plus 2 equals c. So negative 6 plus 2 is negative 4. So our c is equal to negative 4. All right. So if we were to write now the equation that they are now asking us, we'll simply say y is equal to, our gradient is negative 1, x minus what? 4. This is the equation they're asking us. Just like the way we solved this one, and this is how we get to find the equation like that. We first differentiated our given function of that curve. All right. After we found the gradient function, we replaced where there was x with 2. Using these points,